My name is Tilman Buchner, partner at the Boston Consulting Group. I'm very pleased to be here today morning and to moderate the session. We have a great lineup of industry experts with decades-long experiences in digital and manufacturing industries. Before we start into the topic, let me share with you a BCG perspective about what is the Industrial Metaverse. First of all, the Industrial Metaverse, it's not about technology. The Industrial Metaverse is a concept. And this concept helps us to address three key challenges in engineering and manufacturing operations. Let me share with you these three key challenges. Challenge number one is, and I think all of you also experience this, also in today's world where we have great enhancements and achievements and further developments in PLM systems, it's still a difficulty to actually ensure the interoperability across application domains. And especially when we think of, you have CAD applications, you have factory design applications, factory automation applications, all of these applications need to ensure that we can collaborate across these application domains. And we will showcase later on how the Industrial Metaverse in particular can help to ease the collaboration across these application domains. Secondly, when we talk about to leverage artificial intelligence on the shop floor, many companies struggle, especially to unlock the full power of AI at start of production. There are two reasons why. Reason number one is it takes time to capture and collect data, especially when you did a change in the product geometry, for example. And secondly, some of the failures which might occur over time are very rarely, and sometimes it's even costly and sometimes dangerous to replicate these failures to collect meaningful information at the end to generate training data for your inferring models. And we will see later on how the Industrial Metaverse can also help to overcome this challenge and to generate training data sets so that you could immediately start at the start of production by leveraging AI. And third, think of automation technology, think of robotics. I think even with all these new enhancements in cloud edge computing, in IoT, in containerization, in serverless computing, think of generative AI. But think of, even if we have these new kind of technologies, our automation technology in robotics behave pretty similar and the same as we see in the last decades. And I think the interesting part is how the Industrial Metaverse, maybe also in a combination with new approaches in generative AI, enable new handling operations and unlocks automation potentials. And this will lead to that maybe in future we can generate and develop robotic applications capable to handle geometric variances or can handle complex handling of flexible components like a cable harness problem. All of this will be enabled by the Industrial Metaverse. So how could actually the Industrial Metaverse in particular help to address these three challenges? To address actually the problem number one, the interoperability, what we see is that we use combined scene models to actually bridge the different application domains. We call this to build up an integrated factory model. And this integrated factory models, we see companies like NVIDIA and Autodesk with Autodesk Platform Services or the NVIDIA Omniverse Nucleus platforms. They help actually to communicate and to bridge across these different application domains. And they feed in data from these individual application models into an overarching scene model. So now we could actually enhance the collaboration across application domains, but what about our problem number two? Problem number two was that we lack training data sets at start of production. So now think of, we have created these combined scene models in step number one, and now we use synthetic data generation and photorealistic rendering to generate many versions and scenarios of these combined scenes. And this will lead to the ability that we can generate training data sets in simulation, train inferring models, and deploy into reality, so that at start of production, we could identify, for example, possible quality defects right away. And as you see, as BCG, we did an estimate on what the business impact is of these two achievements. On question number one, we see an uptake of around about 25% cost reduction in design changes, because we can fasten and streamline the entire collaboration and development process from product design to production. And also we could increase the ramp-up time when we do a start of production. Give you a concrete example. Think of quality inspection. Many companies, automotive companies in particular, face challenges in the end-of-line quality control. You could save a double-digit million impact if you are capable to identify possible quality defects from the very beginning. And this is where the Industrial Metaverse generates very concrete business impact. And last but not least, and this is maybe a little bit a look into the future, and I think it's getting really interesting if we start combining the achievements and concepts of the Industrial Metaverse with enhancements, what we see nowadays with generative AI. So when the Industrial Metaverse is meeting with large-scale transformer models, we could now really start unlocking new handling operations. And I'm very much looking forward when we build the first robotic transformer models and apply approaches like what we see at ChatGPT and apply this in a different application domain, for example, in the manufacturing sphere. And this will lead up also, there are some promising first results where companies build up the first robotic transformer models with a generalization rate of 80%. This means you train your model based on a large-scale robotic data foundation model, and now you put your robotic application into a different scene, in a different environment, and you even achieve a generalization growth of around about 80%. It depends, fluctuates between 50 to 80%, but this will really be a kind of game changer. So you see in total, the Industrial Metaverse, it's not about a particular technology. It's about a combination of different technology building blocks, powered by the cloud, and it enables really significant improvements along the entire value chain, from engineering to manufacturing and also into particular applications in robotic handling. This is our perspective as BCG, an outside-in perspective on the Industrial Metaverse. But today morning, I'm very pleased to welcome 5 really industry experts covering the entire industrial tool chain, as well as the shop floor. So please welcome on stage Quirin Gertz, CIO of KUKA, Timo Kissner from NVIDIA, Alexander Stern from Autodesk, Grant Bodley from AWS, and Stuart McCutcheon from Siemens. Please give a warm welcome and a hands of applause. So I did a quick round of introduction. So as mentioned, Quirin, you represent the robotics industry today morning, CIO of KUKA, but also part of the board of Visual Components, so also part of the industrial software sphere. Grant, General Manager at AWS. But gentlemen, please, maybe if you want, you could just introduce maybe yourself in 2 sentences.
Absolutely. Grant Bodley, General Manager of the Industrial Manufacturing Industry Vertical at AWS. Do you want to go?
Alexander.
Alex Stern, I head up the manufacturing platform strategy at Autodesk.
So Timo Kissner, I am leading the manufacturing vertical at NVIDIA for the European region.
And Stuart McCutcheon, Siemens Digital Industry Software, and focused on Industrial Metaverse at the moment, and how we bring it to market.
Excellent. Maybe, Alexander, we start with a perspective from Autodesk. So what is the Industrial Metaverse doing differently, maybe more easy from your perspective?
I I don't think different is the right kind of word, because the term metaverse has been given a lot of attention because Meta pivoted towards the metaverse, changed the name. So there's a lot of attention around the term. And the reason why Meta did that, I believe, is because they thought that we reached a tipping point when it comes to the metaverse. But in reality, with these kind of sweeping technology changes, it's a very incremental process. A lot of technologies are developing in parallel. At some point, they converge, and then you have a tipping point where you have widespread adoption. So I don't think, from one day to the next, things are going to be completely different. And a lot of the things that are part of this metaverse idea already exist. So for instance, we already work in virtual worlds. And I'll give you a few examples in a minute. So first point I wanted to make, I don't think the metaverse, industrial metaverse, is something totally different. And it was actually similar with the mobile internet, Mm-hmm. The mobile internet, some people think it emerged in June 2007 on a single day. That wasn't the case. Mm-hmm. A lot of things led up to that. Suddenly it was there. And by the way, today nobody talks about the mobile internet anymore. But that's a different point. So a lot of incremental things are happening to make the metaverse happen. And you asked about what it can make better and what it can improve. What we are seeing as Autodesk, we're very much at the beginning of the whole project life cycle, so in the creation stage. And especially at the beginning, there's a lot of ambiguity. And what the metaverse promises is virtual worlds and interoperability. And that really rich environment can help with a lot of ambiguity. The interoperability can bring a lot of data and simulation from later down the life cycle into the early phase of product and project creation. So I think the metaverse can really help make better decisions early on. And some of our customers are already using it. For instance, Nissan, one of our customers, has a completely virtual automotive design metaverse. It's their own little metaverse. But what they basically have is a completely virtual hall where they have the different design models for their cars. And that allows for a lot of interaction and the kind of chats and discussions you would normally have in real life in a virtual world to discuss the nuances of car design.
Excellent.
And that creates an amazing efficiency.
Excellent. Timo, is this very, very much aligned also with the thinking of NVIDIA, or what's your take on this?
Absolutely, I would fully agree, right? Like bringing all the different data sources together, right? You had it on one of your slides, right? Today we have open standards for creating those 3D worlds, right? Where we can bring together the different data silos, combine it, have a way bigger data density, so to say, right? To help companies improve the transparency, take better decisions early on. Absolutely, that's exactly what we're working on.
Stuart?
Sorry, very much in evolution, right? Yeah. I think industrial metaverse is something we'll see over time. Yeah. There's building blocks along the way, right? And it's going to be a journey to see that holistic, true industrial metaverse. I think one of the differences between metaverse and industrial metaverse is industrial metaverse has to be it has to be an accurate place where you can make true engineering decisions. And I think that's why it's slightly different and it has more value for our end customers.
Excellent. Okay. So we see that the industrial metaverse in particular has great benefits along the industrial software tool chain and maybe also in particular in the engineering and design phase. But what about the manufacturing operations? So let's teleport ourselves onto the shop floor into a real factory environment. What are the implications of the industrial metaverse in this context?
So this is something we're in the middle of investigating heavily. Just exactly what use cases bring value. We actually have an AVI here of a demo that we have running in our booth. And this demo basically is a company we're working with, Freyr. And it's basically looking at a battery plant. And we have a number of different use cases. One of the use cases they want to use the industrial metaphors for is helping them to sell their plant as a product. So they want to sell it to investors and to produce more and more plants. So we've got an operational use case where we're trying to, help them build this plant. This plant you see up here is actually one that's under construction right now. So we have a set of use cases around how to make them build it quicker and build it more accurately from a quality perspective. But really, this is it all basically coming together. So I think this is a good example because we basically ingested data from 20 different systems. There's 80 gigabytes of Revit data we got from Autodesk. We have Kuka robots in it. So we've got lots of different data sources coming together. It's basically a low-code application we developed specifically for this on top of our accelerator platform. It's all running on AWS. And the actual visualization you see and the actual scene that we talked about is Omniverse. So we're basically bringing a lot of different pieces of technology together in this use case. Now, I'm not saying everything's perfect right now. We've learned a lot. But this is trying to show the art of the possible of how we bring it all together. And the goal really is to bring the virtual world and the physical world and merge them together is a key concept of this, so that you can make accurate decisions. I want to be able to design in the virtual world, set it going, and then validate against my physical objects and marry these two worlds together.
Yeah.
Right?
Let me chime in here, Stuart. That's super interesting. So does this mean that not one company can claim we built the industrial metaverse, but the industrial metaverse is more like maybe as we introduce a concept where different companies and vendors can be onboarded and actually work together?
Yeah, so I think that's going to be the evolution of the industrial metaverse, and that's why I think it's an evolution, because even Siemens, we have a broad portfolio, but there's a whole host of things we don't do, right? We don't do BIM, we don't do design of buildings, we don't do landscapes. If you look at the scenes generation here, there's all this extra information, right? We don't have expertise on how to make it photorealistic and make it really, immersive, that you're going to interact with it. Yeah. Those are things that we don't have expertise in. So it has to be an open ecosystem basically coming together to deliver it.
Okay. Now I see there's really great photorealistic renderings, and you mentioned that you brought together gigabytes of data, right?
Hundreds of gigabytes,
So from an AWS perspective, talking about infrastructure and actually also the compute load which is needed to handle and power actually the industrial metaverse. Grant, what's your take on actually the infrastructure, the enablers on this?
So just talking about bringing the ecosystem together to make this all work, and a great segue from Stuart's point of view. At AWS, we really look at the industrial metaverse as the digital twin of digital twins, and how those digital twins interoperate and collaborate with each other across the life cycle of a product, so that you can design your product digitally, test it, simulate it before it becomes physical, be able to simulate manufacturing, ultimately push your work instructions down to the software-defined controls, to be able to have the flexibility to simulate manufacturing changes and really get the benefits that you highlighted a little earlier. Not only to be able to experience the virtual replica of the physical system or object, but actually to ultimately control it. So at AWS, we provide two key capabilities for that. The first is the AWS IoT Twin Maker service, which makes it much easier for you to generate digital twins or digital replicas of physical objects or systems. And it makes it easy because it allows you to bring the data together from where it currently resides, so that you don't have to re-ingest and move your IoT, your video data, your enterprise data. You can actually have a knowledge graph automatically generated that binds the data from your physical objects to the digital replica. And the IoT Twin Maker service, as Stuart mentioned, was core to the Siemens Industrial Metaverse demo that I would encourage you to take a look at the Siemens demo. I took a look at it yesterday. It was really amazing. And I think, Stuart, it took you 5 weeks to pull that together. Exactly. So just in addition, what's holding our customers back from being able to leverage digital twins and the metaverse really is this fragmented landscape of data. So for the average manufacturing customer, their data is very, very complex and siloed. And for a metaverse scenario that we just described, you really need to have a single view of data. You need to be able to pull this all together so it can be represented holistically for that object across engineering, across manufacturing, across the supply chain. And I think the challenge that we have is a lot of the industrial software providers in the past developed applications for their portion of that life cycle, and ultimately a lot of that data, it was really designed to solve the data connectivity problem, connecting to all the different sensors and data sources, and then the data contextualization problem, one ISV at a time. So the poor manufacturer sits there and scratches their head and says, I've got all of these different siloed data environments, how am I going to bring this all together? So that's really the view that we had, and the vision that we had 2.5 years ago was a partner-first strategy to be able to bring our partners together to identify the partners that do the data connectivity and the contextualization the best on the cloud, next generation, and to ultimately enable the software providers to consume that single view of data from an API. Okay. And that's really where we are moving towards, and that follows a lot of the announcements that we've made around our industrial data fabric that you can see in the booths next door with the partners that we have within that space.
Okay. So, Grant, you mentioned some, let's say, technical hurdles and how you can address them. Timo, do you agree? Are there any other elements, maybe also organizational elements, strategic elements, what companies prevents to really start the journey into the industrial metaverse? Or
I mean, in general, I would say the short answer is there's nothing that prevents them from going into the metaverse and starting that journey, right? I agree with what you said before in terms of, look, the biggest challenge is overcoming all those different data silos that we still have there in the different domains, right? I would say if I look at companies today, I would even say many of them are already in the metaverse, right? Look at companies like Autodesk, Siemens. You have been working on applications for 3D visualizations, for breaking up data silos for years, for decades, right? And companies are using them. So that's part of the metaverse, right? And those expert tools, they will always be an integral part of the metaverse. What's new now is that we are able to bring those data sources together, right? In our case, we always talk about the metaverse is a 3D evolution of the internet, a 3D evolution of expert tools in the manufacturing space, right? Not so much maybe of the internet in the industrial space, right? So we are able to bring the different domains together, combine the data, enhance the visibility in the factory, create additional transparency to take better decisions up front, right? And if you combine that then with the simulation capabilities of those tools, if you combine it with AI capabilities, Till, you mentioned it before in your presentation, right? The metaverse, from our perspective, is really something which is the training ground also for AI models, right? I mean, many customers have been stuck in AI pilot purgatory, right? We can overcome that now because you can train it, you can try it out in the metaverse, be faster, be more efficient, and actually also then scale it, right? So, long story short, I think the question is more like, where do you start? From our perspective, it's pretty easy, right? You start with full fidelity visualization, right? This is where we are bringing up the different data sources, have a photorealistic visualization in real time, right? We couldn't do that before. Today, we can do it in real time. We don't need to wait for the rendering to be done, right?
Absolutely.
Then you start combining the simulation capabilities, and then you go into the AI space and leverage the full potential of the combined data sources again, and the tools, obviously.
Excellent. I think when we talk about simulation, right, it's I think a great segue into the robotics, because simulation is of highly importance also in robotics. Corinne, what's your take on, to which extent can we use concepts of the industrial metaverse to further develop and enhance industry robotics?
Well, I think there are two major topics. The first topic I think you also mentioned is this closing the simulation to reality gap, Till. Yeah? When we look at automation or simulation today, we can do a lot of things already in the 3D virtual world, with 3D factory simulation. We can even program the robot offline already. But when it really comes to sophisticated tasks for a robot, there are still some limitations, and there are some some really specialized companies out there focusing really on offline programming of different kind of robots, yeah, but always for specific use cases. So they focus usually on the main tasks like spot welding, arc welding, gluing, machine tending, stuff like that. Yeah? But when it really comes to more difficult tasks, where you need to have maybe more information about the physics of the product, for example, yeah? And my favorite example is usually taking a glass of water. Yeah? For us as humans, it's super simple. Yeah? We're used to it, but even as kids, we were challenged with this task, yeah? Not to spill over the water over the whole table, actually. Yeah? But also for a robot, this is a very complex task because the robot doesn't know about the environment. The robot doesn't know about the physics of the water. It doesn't know about the physics of the glass. Yeah? So when we bring the robot into the metaverse, we can teach the robot a little bit more about the whole environment. Yeah? So and we can then combine it, as Timo already said, with different kind of simulations. We can add synthetic data, for example. Yeah? And then combining all these different kind of technologies or building blocks, we have an environment where we can teach the robot actually how to handle a glass of water securely. Yeah? So this brings in new things, where we can teach robots new tasks that are highly complex, and where we today have no possibilities except of really putting a lot of manual effort in this teaching topic. And the second topic, I think, is also this collaboration topic. As Timo already mentioned, and Stuart also said, bringing together all different kinds of engineers. In our line building business, we often face the challenge that we get some basic information about the plant, about the hall, the production outline, and then we start engineering, we build everything, and then we're facing reality. Yeah? So the architect of the building decided, okay, he needs to put some pillars a little bit more left or right. Yeah? And then we go on the construction site, and we are faced with this situation that the pillar is now 1 meter left or right, and no longer in the place where we expected it. And then we need to readjust in the physical world, which is quite expensive. So if we could bring together the architects, the data from the BIM, the data from our robots, the data from all the other equipments that are needed to build this production line, and all the engineers are collaborating in one kind of virtual space, like the NVIDIA Omniverse, then we have the possibility to figure out these kind of challenges already in the virtual world, do some adjustments on our line building, for example, and then start really the production, and starting to build the production line on site. And this will prevent a lot of mistakes. It will save a lot of money in the end, and I think that's of course one of the biggest benefits also from a line building perspective when it comes to robotics.
Excellent. So let me summarize what I've heard from you, from the experts. My understanding is like a lot of things. On the one hand side, we are talking about industrial metaverse has already been invented, right? So many things, as you said, 3D modeling, kinematic modeling, all of this actually exists since decades. But, and I think that's the new thing, there is a kind of new concept which now helps us to actually bridge these different data silos. Maybe I really like your Omniverse nucleus. Maybe now we can be in the nucleus of the different data models. Yeah. So because as of today we have different application domains with different data models, and I think this is one of the key challenge. How to merge these different data models, because there is a reason why we have different data models, because these different data applications serve different purposes, right? And the nucleus is a kind of, or the industrial metaverse is a kind of common ground where for the first time for us as human beings, we can now merge some parts of this data model to make it visual on the one hand side, so to really have one perspective along the entire industrial tool chain from a product design over factory planning, factory design to factory automation. And then we add another ingredient to it, which is the power of the cloud and the artificial intelligence, which brings us new abilities in synthetic data generation. There's a segue into the topic of generative AI, which is all about also synthetically generate information, which not occur in the real world, but more in a simulation world. And then last but not least, the enhancements in ray tracing and photorealistic rendering to close this simulation to reality gap. Yeah, and maybe this is a kind of messaging which also you can take with you. Yeah? The industrial metaverse helps us really to close this gap so that we can create and simulate things in simulation with an appealing as it looks like in reality. And this gives us a new degree of freedom in automation, which can be used. And I think the good news is it can be used by everyone, because it is available. What prevents companies is, like, I really like your quote, nothing. You can do it. You could use it right away. We're not talking about basic research. It's already usable. And with these words, I would like to, Stuart, for sure, one comment.
I think there's just one extra thing. It's that connectivity to the physical world. You have to create that digital twin.
Yeah.
Otherwise, it's all just virtual. We've been doing virtual a long time, but that connectivity and bringing those two worlds together is a key essence of what will make this right. And that closed loop between it. We talked about digital twins for a long time.
Absolutely.
This is a multitude of digital twins. Models have to have behaviors that really are true.
I really like it. So now we could also add the term of IIoT, so the Industrial Internet of Things now is also connected to the Industrial Metaverse. So now we have a real common ground connecting everything with everything, which is at the end the Industrial Metaverse. I would like to thank you first for taking the time today morning. And I wish you a great day at Hannover Fair, and hope to see you next time, either in the Industrial Metaverse or in reality. Thank you.